Hi, my name is Jelena and I'm a software developer here at FHIR. I first started working here as an intern after I got my bachelor degree in information technologies, and then I stayed later as a full-time employee. And what I really like about working here is the fact that FHIR is a health tech company, so I get to work on many interesting projects that actually help improve healthcare, and also in some cases we get to use technology in help in saving people's lives, and that is something that feels really great.
Hello, my name is Bogdan and I'm a software developer here at FHIR. I've achieved a bachelor degree in information technologies and my expertise is in backend technologies. I do like working for FHIR because FHIR is oriented on creating the softwares in healthcare and software that cures the world. And secondly, I have a feeling that somehow I'm help other people to live better.
Okay, so Bogdan and I recently finished work on a project for one of our clients who is working with a clinical research organization to accelerate medical innovations. So their main goal is to actually provide pharmaceutical and medical companies insights into the world health of trial participants so that new treatments can be developed more quickly. So we have to collect data such as medical conditions, medicine prescribed, and the costs of care. And actually, the way to get access to those patients' data was to integrate our app with FHIR APIs. In this case, those were bluebutton and 1upHealth. So bluebutton is a FHIR-based API for Medicare beneficiaries, and the Medicare is a national health insurance program in the US for people of 65 and older. And this API actually delivers the Medicare claim history for hospital, medical, and drug coverage. So we use bluebutton to get those data. But also we had the participants with coming from other health insurance providers. And for this, we used 1upHealth. And that is a FHIR-based platform that actually connects over 10,000 health facilities. And they're making it easier to access consumer data and health systems in different locations, and they transform it into a FHIR standard and then make it available to us app developers. So they have this quick connect white label app that allows your app to search for patients, connect to multiple health systems, and access their full records. Also, they have a direct EHR integration and this FHIR bulk data platform that transforms and normalizes data, and it enables then API and SQL queries if you need some analytics. And they also have some of their own products for patients and providers for sharing data. And now we can talk about the actual process of integrations with these APIs and how we handled some steps of that process in order to get the data we needed. And the first step is patient authorization. So Bogdan, you can tell us more about that.
Thank you, Jelena. So let's start from the beginning. Okay, well, when the participant comes to a web application, some basic data such as first name, last name, email address, residential address, city, state, and postal code are taken. When this is entered, saved into our database, each participant gets their own unique token ID that we need in the following steps. The participant is then instructed to authorize with their healthcare insurance provider via bluebutton if original Medicare is involved, or via 1upHealth if Cigna, Aetna, or Humana are involved. In the following presentation, further talking, I will use the 1upHealth as the API service as an example. So I will call it the proxy API provider. Participants are required to enter their username and password on the portal of the selected healthcare insurance provider, along with the username and the password. The participant unique token ID, as I mentioned before, client ID and client secret are sent via the backend logic. Based on this unique token ID, we have two verification states. First, if the participant does not exist in the database of the proxy API provider, based on the unique token ID we sent through backend logic, it will be automatically created, and the proxy API provider will return the code variable that will contain the OAuth2 access code. Second state, if the participant exists in the database of the proxy API provider, step where we create the user will be skipped, and we go immediately to the step where we are getting the OAuth2 access code. We send this code in the next step to get the access token, to get refresh token, and to get expiration date of that access token for this participant. The proxy API provider returns our unique token ID through the parameter called state. Based on the unique token ID from the state, we validate and connect the created user at the 1upHealth with our participant. In our database, we enter data such as provider name, access token, refresh token, expired date for access token, as well as the name of the proxy API provider. We will name this as a participant access data. If a participant access data already existed in our database for the required provider and for the required participant based on the unique token ID, the values of the access token, refresh token, and the expiration date of access token will be updated.
Okay, and after participant authorization and getting access to their health data, the main part of our job was actually to parse claims obtained from APIs, and to be more precise, parsing and extracting explanation of benefit properties that were of great importance to the client for the further steps and uses. So what the explanation of benefit really is, it is a statement from your health insurance company providing details on payment for a medical service you received, and it explains what portion of services were paid by your insurance plan and what parts are you responsible for paying. It's not a bill, it just gives you that data, and it helps you track medical care and costs, and it lists all services and equipment you received through the year. So that's why the explanation of benefit was actually the FHIR resource we used the most. And since we use Blue Button and 1upHealth to enable users to give us permission to access their data from their health insurance providers, we also had to cover the case when one participant had more than one health insurance provider. And there we also encountered challenges that needed to be addressed.
Yes, as Jelena mentioned, if the participant wants to add another healthcare insurance provider, the steps will be the same as the authorization for the first healthcare insurance provider. Proxy API provider, in our case 1upHealth API, works on such a principle that for each healthcare insurance provider with which it connects, for a given participant, it stores its data in its database. So every time we are trying to fetch and get to the data, we actually get it from 1upHealth. How useful this is, on the other hand, this was an aggravating circumstance for our approach, because 1upHealth all data, in our case, explanation of benefit, as Jelena mentioned, and their properties of the claims for the same participant and for different healthcare insurance providers, they concat. I mean, they join them into one big array. So it makes it difficult for us in later parsing because we don't know which claims belong to which health insurance provider. Therefore, we decided to make such a logic that there is an insurance membership table that will create a new row for each healthcare insurance provider that participant connects, and the relationship will be made with that participant based on the unique token ID. Accordingly, the participant can add as many healthcare insurance providers as he wants, and based on the provider name, we will be able to extract the data, and if it's extracted the claims, and we will know which claims belongs to which healthcare insurance provider, which later makes smooth work on parsing data.
Okay. And there was one more step in this process of integration that we found a little challenging and also had to figure out the best solution for. So after authorization part is done and provider claims have not yet been fetched and saved to our database, they only exist in the database of proxy API provider. And then after testing sandbox users, we saw that certain participants can have so much data in their explanation of benefit that the default server timeout of 30 seconds is just not enough time to download them or to fetch and store that data in our database. And considering the fact that increasing survey timeout is not a good idea, we came to the conclusion that it is the best to fetch claims through background job worker that is initiated to cron job.
As Jelena mentioned, sometimes it takes over the 30 seconds to pull all the data from the proxy API provider. So it's not possible to synchronously run a request for fetch the claims as soon as the participant comes to web application and registers. In addition, it is necessary to occasionally fetch new claims in order for them to be up to date. For this reason, the background job is called every hour so that the data is retrieved as soon as possible without unnecessary server load. First of all, we fetch all the participants from our database and we loop through them. And for each participant, we are gathering healthcare insurance providers. We loop through the participant healthcare insurance providers, and before fetching raw claims, we have some conditions. The first condition is calling inter method should fetch claims, which returns Boolean type, and check the few next things. First, if column fetch disable at, which is Boolean flag in a table participant insurance memberships, under any of circumstances put to true, fetching the raw claims for this healthcare insurance provider will be skipped. Since the fetch of the new raw claims is performed every 7 days from the previous download, it is checked whether the date of the last download is less than the 7 days. If this method evaluates the true, the next check is whether the access token expiration date is less than the current time, less than now. If the access token is valid and expiration date is less than the now, than the current moment, we retrieve the data and save it in our database in the participant raw claims table. If not, we exchange the refresh token for an access token, we update the participant access data, then retrieve all the data from the 1upHealth and save it to our database in the participant raw claims table. So here we have an example of two nested loops, one for the participant and another for the participant health insurance healthcare providers. When fetch claims, the entire data is retrieved. If the claim already existed in our database, the values will be updated. If it's new, it will be created. In addition to parse claims, raw claims are stored in database for two reasons. First, and the main reason is if the parser does not parse the certain data validly, we can do it retroactively. And if the parser expands for additional properties that need to be parsed. After parsing, the parsed data is stored in the table participant claims by columns predefined for that healthcare insurance provider parser.